Just give me a moment here. I'm finishing up something. Okay. So let's go ahead and take roll. Let's see. This is 1 o'clock class. 9/23/2020. So we've got Dalton. We've got Jacob. Lopez, right? Yeah. And we have, what's your name? Sparks. Okay, both Jacobs today. All right. So, tonight, I asked y'all to get into chapter 4. So, first part of chapter 4, 4.1, has to do with measures of location. And in particular, what we're focusing on with measures of location is central tendency. Okay? So what do I mean by that? Well, when we have data, it can be spread out in different ways. It can all be normally distributed, nice, easy curve to it. It can be skewed one way or the other, okay? And so that's going to change how our data is represented and what is the best data value, so mean, median, or mode, to use to represent all the data, okay? So mean. What do we typically think of mean as being? Starts with an A. Average, yeah, we typically think of the mean as being the average. And so that's usually what we think when we think, okay, we want to represent the data overall, so we're going to use the average, right? Now, median and mode can sometimes be better than mean at representing the overall data. But before we get into that, let's make sure that everybody's up to speed and just calculate mean, median, mode. So let's say we have some data here, 5, 7, 2, 1, 3, 7, 6, and 9. Okay. So before we jump into calculating things, what should we do with all this data? Yeah, put it in order from least to greatest. So we have 1, 2, 3, 5, 6, 7, 7, and 9. Good. So before we work with our data, we really ought to put it in order from least to greatest. So let's start with mean. How do we calculate the mean? Yeah. So we're going to take all these data points, add them up, and then divide by the number of data points we have. So if we add all of these up, I'll go ahead and break out my calculator here. I've got 1 plus 2 plus 3 plus 5 plus 6 plus 7 plus 7 plus 9. I believe that's all. Yeah, 40. Okay, and then we need to divide by the number of data points we have. How many data points do we have here? 8 of them. Good. So divide by 8, which obviously is 5. So we have a mean of 5. Okay? So how about the median? How do we find median? What is median? It's the middle. So it should be the middle of our data. We want to find the middle number in our data. Well, if we count in from each side, we get to here. We have 2 numbers in the middle, 5 and 6. So what we're going to need to do to get our median is what? Add them and divide by 2. Yeah. Essentially what we're doing here is we are getting an average between 5 and 6. And that will always give us the number directly in the middle of those 2 numbers. So 5 plus 6 obviously is 11. Divide by 2, we get 5.5. So they're pretty close together. How about a mode? What is mode? Most occurring number, yeah. So what number occurs the most in this data set? Good. All right. So we've got our mean, our median, and our mode. And for this, actually, they are pretty close to each other. In fact, we would probably call this pretty close to normally distributed. So here's what I mean by that. Remember our histogram? Okay, so histogram, let me just sketch some things out for us. Is where we have these bars that represent the frequency of each of our data points. So how often these things occur. And we can draw a curve around these bars that shows basically the trend that's going on with these things. Okay? So again, these bars represent the frequency of each of the data points. All right, so in a normally distributed data set like this, what we see is this nice curve. And in fact, my art's not great, but if we split this right down the middle, it's symmetrical. So this side mirrors this side. That's what normally distributed or symmetrically distributed data looks like in a curve like this, in a histogram. Okay? Interesting thing about this is that when we have normally distributed data, the mean, median, and mode are all basically here at the center. So the median obviously is there. It's the middle of our data, so it should be in the middle of all this data. The mean is also going to tend to be toward here, because again, it's normally distributed. We take that mean and it's going to fall towards the center. And if we look, the center falls where the center of this hump is. And that's actually also our mode. So remember, mode is the most occurring number. If this is frequency, this is the most occurring one right here. So it's also mode. So once again, in normally distributed data that looks like this, where it's symmetrical, median, mean, and mode tend to fall right next to each other, if not right on top of each other and be the same number. Okay? So which one represents the data best then? Well, since they are all basically the same, at least going to be right close to each other, they all represent the data pretty well. But the correct one to choose, you would typically go with the mean. And the reason we say that is because median only looks at one number, it's just looking at the middle number. Mode only looks at one number, it's the number that occurs the most. But mean calculates using all of the data. Okay, so because it calculates using all of the data, it's more equal representation of the data. It's a fairer representation. So when we have normal distributions like this, mean is what we want to use to represent our data overall. You could think about this as being like heights of people in the class. Our heights are going to be anywhere from like 4.11 to like 5.9 feet. So everybody's going to be somewhere in between there, right? And typically people are going to be right around 5.5, a little bit over 5.5 feet. They're going to be right about here. If we were to average our data, it would be the same. Average people were going to be about right there. So things like height, things that are random, you know, there's nothing affecting how the data is coming out. Your height is just kind of a random number between these two. It's going to be normally distributed. Any questions? Okay, now not all data is normally distributed like this. Some data might be skewed. So I'll just sketch that real quick for us. Okay, just ignore that part, I guess. But as you can see, we have a really steep incline here and then a very gentle decline here. This data is skewed. And we would call this a right skew data. Okay? So the data is kind of piling up towards the left over here. This is where our mode is. Again, this is representing frequency. The height of this curve is representing frequency, so this is occurring more frequently than any other. That's our mode. Our mean is still the middle of our data, so the middle of our data in this case is about right there. Whoops, median. So our median is right there. And then our mean is going to be somewhere on the other side of this median. Okay? So our mean is being skewed to the right. So in this case, mean actually isn't very representative of the data. The mode also isn't very representative because it's just showing us, okay, we have a bubble here. That's basically it. The median is actually more representative of the overall data than the other two measures. And just for sake of completeness, of course, data can also be skewed the other direction. Okay, so this would be a left skew. So our mode again is right in the middle of that hump where it's the highest. Our median is the middle of our data, which is about right there. And then our our mean is right on the other side of it somewhere. So again, median in this case is more representative of the data. An example of this would be something like U.S. incomes. So typically people are going to be making somewhere around here, like $30,000. We said that the lower boundary of this is something like 15,000. or even 12,000 a year. And then the other side of this graph is like millions. Okay? Most people are going to be right around here at this mode. This is about 30,000. But that still doesn't represent the people who are making millions very well. The mean is going to skew towards these millions because they're higher values. It's going to draw it that way. So it's not representative either. So in between, this median is actually a better representation. If we went with mode, well then yeah, everybody in the entire US is making $30,000. Nah, that ain't true. Mean, everybody in the US is making hundreds of thousands of dollars. Nah, that ain't true either. A middle ground between the two? Yeah, our median is more representative. So again, when we have normally distributed, mean is best. When we have skewed, median is probably better. Any questions? Okay. And what about mode? Well, it actually is also useful. So the place that it's mostly useful is when we have categorical data or discrete data. So when I say discrete, what do I mean by that? When I say that data is discrete. Anybody? So each data point belongs to a certain group, a certain category. So like our washing machine, dryer, microwave example that we did a few weeks back, those are all categories. That's discrete data. Continuous data, this is 4.11 to 5.9 and everything in between. This is continuous. Discrete data would be something like popcorn sales at a theater. So how many people buy a small bucket of popcorn? How many people buy a medium bucket of popcorn? How many people buy a large bucket of popcorn? Okay, this is discrete. They all fall into a particular group. And so we could say maybe not a lot of people bought smalls, a whole bunch of people bought mediums, and a decent amount bought large. If we want to show the overall tendency, the central trend, then the mode would actually be the best way to show this. So what is the data overall doing? Well, overall it's going towards medium popcorn sales. So the mode is the one that we want to use here. So mode is mostly useful when we're talking about discrete or categorical data. Again, these are categories. Any questions? No? Makes sense? Good. All right. So again, mean, median, and mode are measures of central tendency, what the data is doing overall. And they can be used for different scenarios to represent the data. All right. So let's look at something new. We know mean, median, and mode. Are there any other measures? Yes. So what I want to show you today is called weighted mean. So weighted mean is where our data values aren't equal. One data is going to have more value than another piece of data. So think about your grades. A has more value than a B or a C, and so on and so forth. A D has less value than most other grades, right? So there's inherent values in these things. And along with those comes weights. So when we want to calculate an average for things that have weights, we need to calculate a weighted mean. Prime example of this is what I was just talking about, grades. A grade point average, a GPA, is a weighted mean. So let's take a look at one of those. So I've got an example here. going to basically write out a report card. So we've got classes. I'll use a ruler here, make this look neat. And let's see, we have on this example that I pulled up online, English class, chemistry, psychology, economics, and interestingly enough, rocket science. Okay, so this school offers some interesting classes. Okay, so at the end of this semester, when you look at your final grades on Banner, you're going to see a few pieces of data on there. Again, first one's going to be the class. The next one you're going to see is your grade for that class. And so let's give this person some grades. So the example that I pulled up says they have an A in English, an A in chemistry, an A in psychology, an A in economics, and a D in rocket science. Okay. All right. The next thing you're going to see is the points that that grade corresponds to, the value that it corresponds to. So an A is valued at 4 points, 4.0. And I'll just put the rest of the scale down here for reference. A is a 4.0. That's how many points it's worth. B is 3.0. C is 2.0. And D is 1.0, leaving F to be worth 0. That's why people say D for diploma. Okay? So let's go ahead and fill in the grade points for this person. So all of these are 4.0s, except for the D, which is a 1.0. Again, these are grade points. In other words, we're translating the letter into a number. Okay, the next thing you'll see is credit hours. So the credit hours is how much that class is actually worth. It's the weight of that class. So English was 3 credit hours, chemistry was 5, because it probably had a lab or something, psych was 3, economics was 3, and rocket science was also 3. 3 credit hours is actually the typical amount that you'll see. Okay. The rest of this we got to figure out ourselves. And that is the weighted value, or in this case, the grade point credit hours. So each of these classes with each of its grades represents a certain weighted value. So we have a value and a weight, and if we multiply them together, we get the weighted value, how much it actually is worth with the weight of the class. Does that make sense? So for instance, this one, 4 times 3 is 12 grade point credit hours. Next one, 4 times 5 is 20. 4 times 3 again is 12. Again, we have 12, and then 1 times 3 is 3. Does that make sense? Okay. So now, we have our values, we have our weights, we have our weighted values. Here's how we get a weighted mean. The weighted mean equals the weighted values, the sum, that's a capital sigma for sum, the sum of our weighted values divided by the sum of our weights. Okay, so again, when you see sigma, it just means you're going to add everything in a particular column. So sigma for weighted values, we're just going to add all of our weighted values. Sigma for our weights, sum of our weights, we're just going to add all of our weights together. So if we add all these together, add our weighted values, we get 59. Add all of our credit hours together, we get 17. So here's our sum of weighted values, here's our sum of weights. We just got to plug them into here now. So 59 divided by 17. And let's see what we get. So 59 divided by 17. And we get 3.4705, so on and so forth. Typically, we want to round these to 2 decimal places. Sometimes even 3. In fact, Sul Ross will round these to 3 decimals, so why don't we do that as well? So this will round to 3.471. So this person's GPA for this semester of classes is 3.471. That's not bad. That's not bad at all. Really, the thing that killed him was getting a D. Oh, yeah. Very close to a 4 point anyway. Okay. Any questions? All right. Then I want to do something kind of fun. I'm going to let y'all see my grades. So I've copied down the data for one of my semesters when I was in college. What? I did indeed. Well, I took a jewelry class and was the lab tech for it at the same time, so easy A. Then I had learning theory, and then this is another teaching class. So learning theory is learning how to teach. Reading content is another class for, it's teaching how students how to read the content in a particular class. And then I had forensic geology. Do what? This is probably the most fascinating class I've ever taken. Oh. Forensic geology? Yeah. So it's using principles of geology, rocks and things like that, to help solve crimes.
Well, I took a forensic science class my senior year of high school. It's my favorite class ever.
Yeah, so one of the best examples that our teacher gave us, Dr. Stark, who's sadly no longer with us, there was, y'all know Coors beer, right?
Who?
Coors beer?
Oh.
Yeah. So the guy who was the owner and guy who made the beer was a guy named Adolf Coors. and he was murdered way back in the day. And they found his car kind of off on a dirt road. And what they did was they took samples of the gravel and dirt and whatnot that was up in his wheel well to figure out where it had been and where it came from. So they were able to like trace out a timeline of where this car had gone, because his body was actually found not far from the car. They were able to figure out where it had gone and get evidence that way. So yeah, very interesting class. Anyway, so I've got an A in jewelry, an A in learning theory, B in reading content, and B in forensic geology. So let's calculate my GPA for this particular semester that I did. So first of all, we need grade points. We need to know how much each of these grades is worth. So what's an A? 4.0. Again, an A is a 4.0. What's a B? 3.0. Okay? So now we need to get our grade point credit hours. So how do we get that? Multiply. Yeah, grade points and credit hours, good. So this will come out to 12, another 12, then we have 9 and 9. Okay. So, what all do we need to total? Grade point credit hours, we definitely need to total that. So let's see what we get. 12 plus 12 plus 9 plus 9 is 42. Okay, and then what else do we need to total? Credit hours, the amount of weight that we had for this semester. So 4 times 3 is 12. Okay. So now what? Divide? Is that what you said? Yeah. 42 divided by 12. So 42 divided by 12. And we get a GPA of 3.5. Not bad. Not bad at all. In fact, if I remember correctly, I made the dean's list that year, or that semester. Now, I'm not going to lie to you. I definitely chose the best semester of my college career. Okay? There were some grades I'm not very happy about, but remember, nobody's perfect. So, that would be how you calculate GPA. And again, GPA is calculated as a weighted mean. Okay? So we have our values and our weights. We figured out the weighted value and then divided it by the sum of the weight. Now these things can get complicated. So this is actually an example that I pulled from Hawks, but it is a hard rated example. So we have a table up here of our weights and our data values. So we have weights like 5.54 and then a data value of 9 for that. And it keeps on going on and on and on. So to get our weighted values, we need to multiply our weight times our data value. And goes down there. Weight times data value goes down there. Weight times data value goes down there. Weight times data value goes down there. Notice that there's pluses between all of these, and that's because we want the sum of all of these. And then we have the sum of all the weights, and yeah, I calculated this by hand. However, I calculated this by hand just to show you that there's an easier way. So, luckily, this class has been provided with TI-84 Plus calculators that we get to use while we're in class. If we need them, I'll pass them out to you for an activity or a quiz or a test or whatever. Okay. So, if we want to calculate a weighted average or a weighted mean on here, what we do is hit Stat and then click on Edit. So click on Edit, the Enter button there. and I've already entered everything in here, but in the first list, you'll want to put your, whoops. In the first list, you'll want to put your data values. So 9923735. That's all put in this list right here. In the next list, I put all my weights. So all of these up here went into the second list. Okay? So then I go back to stats. I don't need to edit anything. I've got my data in there. So I go to calculate. And I hit one var stats, one variable stats, because this is one variable. So, interestingly enough, list one is just the values frequency list. So y'all know what a frequency list is. Interestingly, this counts as our frequency list. So we want to set L1 to our list and L2 to our frequency list, and then hit calculate. And it comes up with all sorts of very neat numbers. It's got standard deviations in there. It's got sums of x squared. But the most important one for us right now is x bar. For this, since we have two tables, two lists, this actually gives us our weighted mean, which, if we compare, five point two four eight nine, 5.2, I'm sorry, yeah, 5.249, because I rounded it. So, works perfectly fine. And in fact, if we do anything like this in class with a whole lot of data, big tables, I will provide you with a calculator and I'll show you how to use that calculator.
How come we're not allowed to use that in stat class?
In Lamar's?
Yes, sir.
Really?
Yeah, no, I was pissed. So the other day, we took a test in her class, and I learned it with a calculator, a review with a calculator, we had a calculator. She didn't provide a calculator, but we always, phone or what, if I was in my room doing homework. And then test day comes and like, did we get a calculator? She's like, no, you can't use your phone. I'm like,
well, so that might be because of the content that was on that specific test.
Okay.
So she may have basically put content on there that she said you won't need a calculator for this.
I asked her, I was like, I don't have a calculator, and because I did everything I could without a calculator, and there were things I could have done that would take me a very long time without a calculator, so I'm like, I can't do this without a calculator, I can do a bunch of mistakes. So I asked her, I was like, hey, do you have one I can use? She's like, no, if you want me to go and you get it. But then she told me, all I have is a drafting calculator. She said I wasn't allowed to use that, so I had to go to a buddy's dorm and ask them if they had a calculator.
Okay, well,
Well, maybe after she learned her lesson after our class.
well, I do know that after that quiz, she came and asked me for calculators that we could lend out, and I gave her a whole basket of 4-function calculators. So she probably just didn't have access to them then. So I apologize for that. But let's say it this way. If we need a calculator in this class, I will provide you with a calculator. How about that? And I know when y'all are going to need a calculator because it's the stuff I need a calculator on. This is just painful to do by hand. Okay. But, I mean, really what we're doing is just the same thing we did here. It's just a lot of stuff. This one we only have, what, 4 things? This one we have 1, 2, 3, 4, 5, 6, 7, 8 things. So twice as much. Yeah. So, Quiz Friday. It's going to be going over the stuff that we've gone over today. Mostly going to be this. So, know how to calculate mean, median, and mode. Maybe range. I don't know. Know when they are appropriate to use to represent our data. So, the central tendency of our data. And then I'll probably include something like this. I'll give you a table to fill out with grades and then find the GPA. Sound good? All right, so that'll be Friday. Until then, I hope you have a great day, and I'll see you. I absolutely can, sir. You got one too? All right. Give me a moment while I look up grades. Actually, I'll tell you what. Meet me at my office. Right outside of it.